Alright, so this is a video for LAB7, and as you can see from the slides, that's pretty long, and so I will probably cut this video into two parts. Anyway, so first you will need to start an X, and if you're on the lab computer, you will be opening the file from here, and you need to find your folder, which is in my case this here, and we will start from the FEM obviously, but first you want to change the file of type into FEM. We only have this parts here, so the FEM, and open .fem file. Alright, so from the last lab we have made this only the wheel. Okay, so in this lab we will make the 2D shells for the dolly body and the wheelbase, and after we make this, we will reflect those to the other side, so we will have a third of the whole model. Now those pieces, they're not connected, so after this we will do a FE assembly. So what does that mean? That's basically we add the spiders, the bushings, and some C-bars to connect those pieces, and to make sure this wheel can rotate on its axles, and the sub-assembly can rotate on this vertical axle. Okay, now next, before you reflect this 1/3 into a whole model, we need to do some check to make sure this the connection or the assembly is correct, because once you reflect, all the errors in this unit will be reflected as well. So you want to make sure this 1/3 model is absolutely no problem. Alright, so after you got this the whole model, we will create two extra coordinate systems for the C-bush, because C-bush needed some coordinate system. It doesn't have a coordinate system by itself, so you have to assign a coordinate system to it. And unfortunately, we have two pairs of C-bush, or the bushings. They need to rotate on an axis that's not X or Y. Those axes are at angle to the X-axis. So that's why we need those two extra coordinate system. Then lastly, we will assign the material to the shell, the bars, and the wheel. Alright, let's start. So once you get in this FEM, okay, we need first to create those two pieces of 2D shell. So let's find out the body and the wheelbase. Okay, so we're going to make the shell on the outside surface of those polygons. Let's first find 2D mesh. Okay, and for the wheelbase, the element size will be 0.05 inch, and element type is C-4, which is a like element with 4 edges, and it's linear, so you have 4 nodes. So here, make sure the method is on tangent surface, because we need the outside surface, which they are tangent to each other. So once it's on the tangent faces, and if you click one of the face on the outside, you'll pick the whole outside surface of this wheelbase. Okay, so once it's done, you can either preview your results, Okay, or you can just click apply. Now for the next piece of 2D shell, we'll be using 0.1 inch as the size, and again we're going to use tangent faces as a method. Now I'm going to pick the outside face of this body. So let's take a look at what happens if there's no method. So you have to pick them one by one, which is not too hard for this piece. Okay. So some pieces you would have like a lot faces. So anyway, that's the face we need. And 0.1 inch, you can just click OK. Now we have two faces, and if you expand this 2D connection, you can see we have two collectors. Okay, and the first collector is for the wheelbase, so I'm gonna change the name to wheelbase. And for the second collector, that's the dolly body, so I can change that to body. And if you like to, you can change the color of the collector by going into this edit display, change the color to what we have in the slides. So I'm gonna make it the same as the slides, and also this tells me that those two pieces are in different collectors, because usually the color is assigned to one collector. So we can also change the color of this wheel. In my slides it's kind of different. Maybe it's this color. Alright, now okay, so we have this half of a third. Right, now next we're gonna reflect those two pieces. So I don't need the solid wheel on the screen. I can have the polygon, which will not be picked up as element for reflection. So again, for reflection, insert an element, then you can go for copy and reflect, which is kind of deep in the manual. So what I did is I right click here and I take out this as element operation. Yeah, so that's the element operation manual, which will have everything you need in this insert element manual. So we have create, we have translate, we have this copy and reflect. So I don't have to go back into this menu every time. Now pick everything on the screen and make sure that's the two pieces of the 2D shells, and specify a plane, which is this polygon plane, polygon face. You will need a polygon as to pick up a reflection plane. Alright, now that looks good, and we can just click OK. So we have this reflection, and if you remember from last lab, every time you reflect a piece of mesh with a cutting edge, which is this, in this case it's in the middle, so you will have double the nodes on the cutting edge, and you would like to do an element edge check for the free edge, okay, for those pieces. So I can pick them all, and let's go to static wireframe. And if we generate the element outline, you can see we have two lines in the middle of those two pieces. That indicates they have a cut in the middle. So we need to merge them. And let's go for duplicate nodes, which will bring out the duplicated nodes on this internal edge. So then we merge those nodes. We also merge those two pieces of mesh. So you can go back to element edge check and pick everything, generate this outline. Now you should see the correct outlines. Alright, so that's a piece of cake. Then for next part, we'll be creating the connection between these three pieces of mesh. So first we're gonna grab the wheel into the center axle and also grab the wheelbase into the center. Then we will put a pin or a beam through the wheel, and we will put in joints between the beam and the wheelbase. So that's the idea. Okay, now we don't need the body. We can turn this off. Actually, we don't need those meshes as well. So the idea is we insert RBE2 elements, which you can see from here. 1D connection, RBE2. So that's your rigid connection. This connection, you will need a center node as this source, and the target would be the edge or the nodes on this edge of the hole. So that means we need a center node before we create this RBE2 element. So we need to insert the nodes, and by inserting the nodes, insert node and create, you need to snap to the center of this circle. However, there's nothing you can snap to on the mesh. You need to bring out the polygon. So find the wheelbase, and actually you need 2 pieces of wheelbase. So okay, that's here. So we have this 2 pieces of the wheelbase. Now we can snap to the polygon edge and find the center point of this this hole, as well as this is also the center point of the hole on the mesh. However, we cannot snap to the mesh. That's why we need a polygon. Okay, now those are 2 nodes for this wheelbase mesh. Now we need to call out this wheel polygon, and you can turn this off if you want to, and then insert a node at the center point of that hole, and on the other side also it's the center point on this hole. So your model should look like this, with 2 nodes on the center of the wheel hole, and the other 2 in the center of the this wheelbase hole. Okay, and it's also in this picture with some arrows. Now next we are going to create the RBE2 elements, aka spiders. So let's turn this off. We can first create the RBE2 for the wheelbase. So let's go for the 1D connection, and for the source node, that's going to be the center. So usually the RBE2 or the spiders, the source nodes are always the center nodes, and the target would be the nodes on this edge. So here we have a couple different ways to pick them. Of course, the most basic way is just click them one by one, but I cannot do this if this is like 1,000 nodes on this edge. So we have a method, first method, related nodes. Okay, so for related nodes, it's the nodes that's related to the polygon. So you need to bring out your polygon, and you can click this polygon edge. So be careful, don't pick up the face. You have to wait for that 3 dots and pick from this menu. You want to pick this polygon edge, and those are the nodes that sits on the edge of this polygon. So that's how it's related. Okay, that's one of the methods. And we can create this one first using this method. Then for the other side, okay, the source again is going to be the center, and the target will be using another method, which is feature edge nodes. So as you can see, we have edges right around this hole, and those edges they have certain degrees. Like those two, it's probably like 160 degrees between them, or you can say the smaller angle, that's going to be about 20 degrees. So the future edge nodes will pick up the edge that within certain tolerance of the angle. Say if I click this one, it only picks up 2. That means this edge is outside of the tolerance, the angle tolerance. So if you click this arrow here, we can adjust the tolerance to make it bigger, maybe 45 degrees. So now the tolerance is bigger, and let's click the same edge. Now you can see all the nodes on this circle is picked up, because this edge is between, the angle between those two edges is probably bigger than 30 degrees. So now we change that to 45 degrees. So this angle is within this tolerance. Then it will pick up this edge. Then after this edge, the angle between those two are still also within this tolerance. So keep going this way, it will pick up all the nodes on those edges. So we have the source node, we have the target nodes. What's next? We need to change this destination collector. We want to put those RBE2s that belongs to the same mesh in the same collector. So we already have the first RBE2 for the first in this first collector. So we can put the second RBE2 in the same collector. So just click OK, and now in this collector we have 2 RBE2s, or 2 spiders. And it's the same as the other collectors. We can change the display. We can change the thickness of the line. So basically RBE2 is like lines. Then we can change the color of this RBE2, and look at the RBE2. If we click OK, and that's a little bit easier to see. Okay, so that's the way how we create spiders. Then we will create spiders for the wheel. So it's kind of messy, so I'm gonna hide the RBE2 on the wheelbase and hide the wheelbase. Now we have 2 nodes left. Okay, we use the other 2 for the wheelbase. So now again, that's 2D mesh, 1D connection. Sorry. So 1D connection, the center nodes is the this one as your source. The target, we're going to use feature edge nodes again. This way I don't have to turn on and turn off the polygon all the time. So pick this one, then we will have all the nodes on this edge. And this RBE2 belongs to the wheel, so I'm going to create another collector to distinguish from the spiders on the wheelbase. So apply, we have this one, and for the other side we can do the same and pick that edge. Make sure this one is on feature edge nodes. So this time I need to put this spider into the second collector, which is for the wheel. So now if you look at the tree, okay, we have this collector for the wheel, and we can change color as well as the thickness. You can also change the name if you want to. So this way it's easier to find them. So this is a wheel, so probably it should be wheel, and that will be a wheelbase. Okay. This is not required because spiders, they don't have physical property like dimensions, material, thickness. They don't have that. So you can technically you can put them in all in one collector. It will not affect your results. Okay. But this way we can tell the difference, like which part they belong to. Okay, now if I hide the wheel, now you can see the pink spiders. They're grabbing the wheelbase, and this is a rigid connection. So if you put any force or any torque on the center node of those pink RBE2s, it will be transferred into this wheelbase, and the same goes for the wheel and the spider on the wheels. So how do we connect the wheel to the wheelbase? Here we're going to insert a C-bar element, or sometimes Dr. Zada will call this a bean. A C-bar, a bean, a pin, it's the same thing. So the question is, how do you insert this? And so here's the idea. We're gonna fix the bean onto the wheel. So we will use the node, the source node of the RBE2s on the wheel, which is the red ones, as a node on the bean. And as to the side, we cannot connect the bean directly onto the center node of this the pink RBE2, because that way it will fix the pin on the wheelbase. So we need to separate the pin from this RBE2. So we need another node at the same location of this RBE2, and click here, insert this node, and also insert another node on the other side. So now the wheelbase and the pinkish spider, they are a fixed, a rigid connection. Now we can turn them off. However, this node has not connected to the spider on the wheelbase, or the pinkish wheelbase, the pinkish spiders. So we're gonna use this node, the center node of this RBE2, center node of this RBE2, and this node, the four nodes, to create a bean, which is a rigid connection. So that explained here, from the node to the RBE2 to this RBE2, then to the node. So you would insert another element and create. After we pulled out this bar, this menu bar here, you can just click this icon. Create the element. That will be C bar, okay, for the pin. So auto creation, create a new. Now we're just making a cantilever beam, as we did in the class homework. Now for the second section, you want to make sure this one adds up to the existing mesh, which is here. So this whole beam has 3 sections, but only one mesh. To make sure this one is added to existing. So now I can close this. That's my beam, which is only one mesh. rigid connected. Also, this node in the middle of the spider is shared by the spider and the beam. So that's a rigid connection. And however, if you hover your cursor here on the wheelbase side, you can see two nodes. One is on the spider on the wheelbase. The other one is on the beam that's connected to the wheel. So, as I explained in the slides, the first structure here is rigid connection. The second structure here is also a rigid connection, but the first and the second, there's no connection between them. So to put it simple, if we pull this wheel, it will come out with the red spiders and the bar. Okay, and the pinkish spider will stay on the wheelbase. There's no nothing between them. Now, next step, we will create a joint between the first and the second rigid connection, or the first set of structure to the second set of structure. That will be the C-bush. So you can consider C-bush is a adjustable joint. You can let it be a rotational joint or a ball joint. It depends on the stiffness you gave it. So how do we create a C-bush or bushing element? Again, it's going to be element to create, and a 1D element type would be C-bush. So remember, we have two nodes here, and they're not connected. Now we are picking up both of them. First one, then pick the second one. So now they're connected by a C-bush. And to the other side, make sure this time you need another mesh instead of add to existing. We will use create new. So this way, those two joints, they're not going to mess up with each other. So pick this one and then click the second time. Okay, so now the center beam is connected to the wheelbase, okay, through this spider. You can tell from this collector here. However, we want to see the C-bush elements, right? So you're going to right click and edit display. Here we can enable the text for this element, for this collector. If you click OK, you can see those SP letters at the location of this bushing. And probably your letter is very small compared to mine. So you can change the font size in here, preference, visualization, and in this you can find this color and the font tab. And you can change the size to anywhere you feel comfortable. So that's the size of your font. Okay, so that's how you make the C-bush. And if we double click or right click monkey wrench, you see we have a C-bush property here, and the monkey wrench again, we can assign the stiffness for this bushing element. And if you look at our model, right, the wheel will rotate on x-axis. This C bar or this beam is parallel to x-axis. So if we want this joint to be able to rotate only on x-axis, we're going to free the x rotation direction. As to the other degree of freedom, we're going to type in 10 e to the 8. Then we can just copy and paste for the other 5. So this way, this joint is only free on the x rotation direction, which is a pin joint. Okay, sometimes you can free all the rotation, so it's gonna be a ball joint. And that's good for the stiffness. Next, as I mentioned at the beginning of this lab, the C-bush does not have a coordinate system. So even though we assign, okay, you should rotate on the x-axis, but it doesn't know where the x is. Why? Because if you, I don't know why though. It's like a point. There's no direction for that point. So if you pick both of them and right-click, edit the mesh associated data. Okay. In here, you want to enable the coordinate system override. So we're gonna override or give the C-bush a coordinate system, and that system will be the absolute system, which is this one. So now the x for the bushing is the same as the x for this absolute system. So that's good for this assembly. We can continue to the next step, which is the connection between the wheelbase and the body.